Hello everyone, welcome to Vardhaman College of Engineering. I am Dr. A. Kishore Kumar, Assistant Professor, Department of Chemistry. In Engineering Chemistry course, we have water and its treatment. In this module, we are discussing treatment of boiler feed water. So in this method, in previous sessions, we have discussed internal treatment of boiler feed water and external treatment of boiler feed water, right? So today we are going to discuss ion exchange resin method. So ion exchange resin method. Here we are going to use organic compounds, right? So insoluble cross-linked organic compounds we are going to use in ion exchange resin method, right? So in this method, we are going to remove the ions which are present in the hard water. So ions means here. So generally, if you go for a hard water, right, hard water will contain right n number of salts, right, like temporary hardness causing salts and permanent hardness causing salts, right. So calcium based salts, magnesium based salts, right. So broadly here, any salt, any salt you take, that salt is made with cation and anion, right. So here in ion exchange resin method, irrespective of the particular cation, all the cations we are going to remove and all the anions we are going to remove, right. So in ion exchange resin method, right. So after a hard water is passed through this method, right, all the ions, all the cations and all the anions we are going to remove. That leads to complete removal of dissolved salts which are there in the hard water are removed by adopting this method, right. Let us discuss here. Ion exchange resins are insoluble. Ion exchange resins are insoluble cross-linked, right. So ion exchange resins are insoluble cross-linked long chain organic polymers with a microporous structure, and the functional groups attached to the chain is responsible for ion exchange properties, right. So here each word is important. It is insoluble because it is made with organic compound, right. So here 80 to 90% is organic compound in this resin, and which are having a cross links, long chain organic polymers, and also having a microporous. So microporous are very important because water, to pass the water, right. So here micropores are required, and here functional groups, right. Here functional groups are responsible for the ion exchange, right. So particular functional groups are there, right. So for cation exchange, acidic functional groups, and for anion exchange, basic functional groups are there here, right. So cation exchange resin, which is abbreviated with R H plus, right. So here R means organic polymer. R means organic polymer. Here also same in anion exchange resin also R means it is a organic polymer, right. So in cation exchange resin we are abbreviating with the RH, right. So here strongly acidic and weakly acidic SO3H plus and COOH plus are available in cation exchange resin method. This H plus will be replaced by cations, right. So exchange of H plus and cations takes place, and here in anion exchange resin method OH minus, right. So exchange of this OH minus and chlorides or sulfates or nitrates takes place, right. So here two types of functional groups are available. Cation in cation exchange resin method, acidic functional groups. In anion exchange resin method, basic functional groups are there. In this again strongly acidic and weakly acidic, and in anion exchange also strongly basic and weakly basic functional groups are available. So here important points are, in cation exchange resin method H plus ions are there which are exchangeable. In anion exchange resin method, OH minus ions are there which are exchangeable. Let us see the structure of cation and anion exchange resin. So left hand side cation exchange resin and right hand side anion exchange resin. So in this diagram you can observe, as we discussed in previous slide, that is a long chain organic polymers. So you can observe here chain. These are a long chain organic polymers and which are having cross links. You can observe here cross link between these chains and specific functional groups. Here coming to cation exchange resin method, functional groups are there: SO3H, SO3H, SO3H and SO3H, and that side also same thing, long chain organic polymers which are having cross links and also specific functional groups. Here you can observe basic functional groups, right? So you can observe here highlighted exchangeable protons along with the acidic functional groups, and that side highlighted OH minus ions with the basic functional groups, right? So here R represents a alkyl group, right? So methyl, right? Next let us see how we are going to solve the water, right? So here first, so here two chambers are there. So left hand side, so this portion is for cation exchange resin, and this side, this portion is belongs to anion exchange resin, right? So in cation exchange resin, right? So a bed is there, a resin bed is there. This is a resin bed, right? As we discussed, right? Resin bed, a resin bed is there which is having a very fine pores, right? In anion exchange chamber also a resin bed is there, right? So first we have to pass, or we have to supply hard water. So here we are supplying hard water. That hard water passes through this bed, passes through that bed, right? And we are abbreviated that bed with RH plus, right? So here all the cations which are there in that hard water will react. Here I am writing M plus, right? Cation, right? Now this H plus ion will come out, that H plus ion will come out, right? And here I am writing Rm, right? So here in cation exchange resin bed, all the cations will exchanged by this H plus ions. Now whatever the water is coming down, now this water we can call as cation free water, right? So in this water now cations are absent, anions are present, only anions are present, right? So that water is passed to another chamber, next chamber, where anion exchange resin bed is there, right? So that bed we abbreviated with ROH minus, ROH minus. Here exchangeable OH minus ions are there in this bed, right? So all the anions will be exchanged here, right? So now here only OH minus ions, and earlier here along with anions only H plus ions will come down, right? So here OH minus ions and H plus ions will come out, but not any salt or any cation or any anion, right? So at the end H plus and OH minus again H2. At the end we are going to get a soft water, right? So in cation exchange resin bed, cations are removed. In anion exchange resin bed, anions are removed, right? At the end we are going to get a soft water, right? After using number of days, or after using multiple times, right? So these two cation and anion exchange resin beds are going to get what? Saturated. That means all the functional groups, will be captured by cations and will be captured by anions, right? That means no free cation exchange functional group, and this side no free anion exchange functional group will be available, right? In such case, instead of going for a new cation exchange resin and new anion exchange resin, we are going to use simple chemicals to regenerate cation and anion exchange resin bed. So here those chemicals are dilute HCl and dilute sulfuric acid to regenerate cation exchange resin bed. So here take dilute HCl or dilute sulfuric acid, which will provide number of H plus ions, right? You spray that dilute acid on the used cation exchange resin bed. so that cation exchange resin bed will be regenerated, right? That is again ready to use. And this side use again simple chemicals, cheap chemicals, right? So potassium hydroxide, sodium hydroxide, right? So dilute potassium hydroxide and dilute sodium hydroxide, they will produce OH minus ions, right? Again spray those OH minus ions, that means dilute bases, on used anion exchange resin bed. Again here this anion exchange resin bed is regenerated, that is ready for reuse. So in this way we can regenerate both cation exchange and anion exchange resin beds. Yeah, so here reactions. So in cation exchange resin bed, RH plus reacting with calcium plus 2 and magnesium plus 2 ions. So here calcium plus 2 and magnesium plus 2 ions means they are associated with another anions. For example, calcium plus 2 means calcium sulfate, calcium nitrate and calcium chloride. Magnesium plus 2 means magnesium sulfate, magnesium nitrate, magnesium chloride, magnesium bicarbonate, right? So we are getting what? Exchange of H plus ions. Exchange of H plus ions. Here H plus ions are coming out, right? So this is a resin bed. Now this resin bed is captured what? Calcium plus 2 and magnesium plus 2 ions. So anion exchange reactions in anion exchange chamber. So whatever the sulfates, chlorides, nitrates are there, so those are going to exchange by this OH minus ions, right? So then OH minus ions are coming out, right? So those sulfate, nitrates and chlorides are captured by anion exchange resin. This R means what again? Resin. So at the end H plus ions and OH minus ions are coming out. Again we are getting what? Water only, no any other byproducts we are getting. So regeneration, as we discussed in previous slide. So regeneration, for the regeneration of cation exchange resin bed, add dilute HCl or dilute sulfuric acid, so that you are going to regenerate cation exchange resin bed. This RH plus means what? Cation exchange resin. Cation exchange resin. For the regeneration of anion exchange resin bed, add dilute sodium hydroxide or potassium hydroxide. We are going to get anion exchange resin bed. This is an anion exchange resin bed. Right, next advantages. The process can be used to soften highly acidic alkaline waters. It produces very pure water of hardness nearly 1.2 ppm, because here any salt can be softened, any salt can be removed here, because all the cations and all the anions we are removing. So the treated water by this method can be used in boilers. And the disadvantages, the major disadvantage is the cost of the resin. That is one disadvantage. And next disadvantage is very fine pores are available, right? If we use turbid water, if the hard water is more turbid, those pores will be blocked. So that's the reason turbidness of the hard water should not exceed 10 ppm, right? So that is another disadvantage. Thank you.